So any student is facing problem to join, ask them. Who is CR? Who is CR of this class?
Ishank Singh.
Ishank Singh है sir.
He is here.
No, sir.
Sudhanshu Kumar. Sudhanshu Kumar.
Good
Sir
afternoon.
वो मेरी दूसरी
To whom you are calling?
Good afternoon, sir. I am Ishank.
Okay. Please see if any student facing problem.
Yes, sir. I'll put a message in the chat.
Okay.
Excuse me, sir.
Yeah.
Sir, a few students have problem logging in into Microsoft. Sir, most of our classes are on Google Meet. So, sir, if you want, we can have this class also on Google Meet.
What is problem in Microsoft team? I think most of the student has joined.
Sir, yes, most of the students have joined, but a few students can't.
They will
Join.
also join. If they will sort out the problem, they will also join.
Okay, sir, I'll convey the message.
So first of all, you tell me how much syllabus has been covered, and is there any difficulty in the covered syllabus? If there is no problem, then we go further. Otherwise, you may discuss with me. So, CR, just you tell me how much syllabus has been covered.
Yes, sir, I'm checking just a minute.
You don't remember?
No, sir, I was talking to a child who was unable to join. Sir, radius, curve tracing, tak we have.
Curve tracing is completed.
Yes, sir, it was going on.
It is going on. Which type of curve tracing? Whether it is Cartesian, parametric, yeah, polar.
Sir, only
Cartesian. सर कार्टेशियन वो भी अभी स्टार्ट हुआ था.
Only Cartesian is in the syllabus. Okay. So the tracing of Cartesian is over, or you want to repeat it again?
The theory for it is completed, and ma'am has covered only single example for it.
Okay. So this screen is visible to everyone.
Yes, sir.
Yes, sir.
So always sit with your copy and pen so that you could write whatever I am telling here. So again, I am starting again from the curve tracing of this Cartesian curve, and then I will tell something about the integral, because the curve tracing actually this is not in the syllabus, but when you go for the application of the integration, then there is need of to trace the curve. That's why this curve tracing is important. So as you, I think you are aware, just I want to here repeat again, and then I will take some example. So whenever you trace the curve, tracing of curve. Okay, so here we are taking the Cartesian curve. Cartesian curve means like y is the function of this is x. Okay, so you first one, you have to see the symmetry of the curve. Symmetry of the curve. So there are several rules how you can check the symmetry, because this symmetry, if you draw the curve in one coordinate system, either in this coordinate system or if it is symmetrical about the y-axis, then similar curve you can trace in this coordinate system. Okay, and if it is symmetrical about the x-axis, then you can draw the similar curve in this coordinate. And also you can, this is the symmetry about the origin here. So if any curve is there and if it is symmetrical about the origin, then the similar curve you can plot here, or if it is here, you can plot here. Okay, so this is the benefit of to know the symmetry of the curve. So the first one is that you know, if only even and only even power of y occurs in the equation of the curve y is equal to fx, then the curve is symmetrical about x-axis. Very simple example, you know, y square is equal to 4ax. Okay, so here the power of y is even, that is y square. Therefore, this total curve is symmetrical of x-axis. This is symmetry about the x-axis. If even power of x, is there, then it is symmetrical about x-axis. And similarly, this is the first one. And the second one is that if even and only even power of x occur in the equation of the curve is symmetrical about the y-axis. That is y-axis. So if even power of y, then it is symmetrical about x-axis, and if it is odd power of even power of x, then it is symmetrical about y-axis. For example, just you can take the this one, x square is equal to, this is 4ax. Okay, so this is the symmetry about x and y. It means that suppose if we plot a curve of this in this coordinate system, suppose like this one, then since it is symmetrical about x-axis, that's why we can, without doing anything, we can show that yes, the curve of this is a symmetry, therefore the portion of this curve below this x-axis will be this one. And similarly for this one, if it is symmetrical about y-axis, so it means that if there is any curve like this one in this coordinate system, y-axis is this one, therefore it is symmetrical about this y-axis. So there is no need to draw the whole curve from here to here by the rule. Just by seeing the symmetry of the curve, you can draw any curve in one coordinate system only, and then similar curve you can draw in the other coordinate. Now third one is that if suppose x and y are interchanging, means you replace x to y and y to x, x to y and y to x, and the curve remains same. There is no change in the curve. The curve remains same. Then it is symmetrical about the line y is equal to x. So for example, suppose x cube plus y cube equal to 3axy. So if you interchange x and y, you write down in place of x as a y, in place of y as a x, and here again this is of y and this is of x. You will find out there is no change in this curve. This curve remains same. Therefore, we can say that the curve is symmetrical about the line y is equal to x. How you will find out this one? So y is equal to x line is this one. This is y is equal to x line. Okay. So if any curve is below this line, y is equal to x, and it means that symmetry, due to the symmetry y is equal to x, this curve will be symmetrical like this one, is this one. Okay, so this is the symmetry about the line y is equal to x. So you have to check whether, because here there is no even power of x and y. Okay, so therefore this third rule will be applicable. Just you have to replace x by y by x, and if the curve remains same, then it is symmetry about y is equal to x. Now fourth one is that if suppose x is changing to minus x and y is changing to minus y, you change x as a minus x, y as a minus y, and if the curve remains same, if the curve remains same, then it is symmetrical about the it is symmetrical in opposite quadrant. This is in opposite quadrant. Okay, so you change x as a minus x, y as a minus y, and if the curve remains same, then the symmetry in opposite quadrant. Opposite quadrant means if it is there, then it will be here also. If it is there, then same curve will be here also. This is the opposite quadrant. So it means that let us say the example xy is equal to suppose c square. So you change x as a minus x, so this is of minus x, y as a minus y, that is minus y. Now this is again xy is equal to c square. So the curve remains same. That's why whatever the curve is there in this quadrant, the similar curve is in the opposite quadrant also. Okay, this is the
सर एक स्टूडेंट आना चाहता है सर, काफी देर से वेट कर रहा है, 10 मिनट से लगा पड़ा है.
I don't know what is the problem with him, because I have here solved all the problems. Yes, said to join. Now the fifth one is that if x is replaced by suppose minus y and y is replaced by minus x, and if the curve remains same, okay, x is replaced by minus y and y is replaced by minus x, and if the curve remains same, then it is symmetrical about the line y is equal to minus x. Here x is replaced by y is replaced by x, then it is symmetrical about y is equal to x. But here it is x is replaced by minus y and y is replaced by minus x, and the curve remains same, then it is symmetrical about the line y is equal to minus x. Okay, for example, if we take suppose x square plus y square, this is equal to 3axy. Then you see, if we replace x by minus y and y by minus x, then this curve remains same. So it is symmetry about the line y is equal to minus x. Okay, so these are the points you have to see whether the curve is symmetrical about x-axis or y-axis, or y is equal to x, yeah, in the opposite quadrant, or y is equal to minus x. After that symmetry, once you check the symmetry, then you have to find out the tangent at origin. Tangent at origin. Okay, because this will give the direction. Once you find out the tangent, then it will give the direction of the curve. So how, first of all, you have to check whether the curve passes through the origin. If the curve passes through the origin, origin means you have to put x is equal to 0, and if you are getting, by putting x is equal to 0, you are getting y is equal to 0 in the curve y is equal to fx, then you can say that yes, the curve passes through the origin. So we are going to find out the tangent at the origin, not any other point, but tangent at the origin. So first of all, you have to see whether the curve passes through the origin. Yes, if it is passes through the origin, then you have to find out the tangent. So how you can get the tangent at the origin? Anyone can tell me?
सर वो होता नहीं है, x² को x(x1) में चेंज कर दो और
Sir, equating the lowest degree terms to
0 को इक्वल करना है.
Yes, equating to 0, the lowest degree term, okay, in the given equation. So if the curve passes through the origin, then to find the tangent at the origin, the rule is that equating to 0, the lowest degree term in the curve equation. जहां जहां भी लोवेस्ट डिग्री है उनको हम लेकर के करेंगे. You can get the tangent at the origin. If this equation has a suppose y is equal to fx is of degree higher than 1. Suppose if it is 1, then it means that it will be either x is equal to 0 or it will be y is equal to 0. So this will be the tangent only. Okay, but it is, if suppose degree is higher than 1, then it means that it may come x square equal to 0 or it may come y square equal to 0. Okay, so therefore if there is only linear, here x is equal to 0 or y is equal to 0, so therefore it means that there will be a tangent at any point on this curve, whether whether it is with the x-axis or it is with the y-axis. Okay, but if it is suppose x square, so you cannot write this simply. This is x is equal to 0. Yes, x is equal to 0, but here if x is equal to 0 is the tangent, it means that here x square or y square is there. Therefore, there will be the branches at the point touching this curve means tangent at x is equal to 0 or y is equal to 0. It means that this will be like this one. Suppose the curve is this one, and this is the tangent. X is equal x-axis is the tangent. Okay, so this will be not the single curve here, but there will be other curve here also. Therefore, this at x is equal to 0, there will be the branch of this curve where it will act, this x-axis will act as the tangent at the origin. Okay, so if it is not linear, if it is suppose quadratic, degree 2, then there will be the branches. If it is suppose x cube, it means that 3 branches will be there at the point x is equal to 0, for which there is a common tangent. Okay, but always it will be not common tangent. Suppose a curve is like coming like suppose y lowest degree coming like this one, y is equal to plus minus x. It means that there are 2 tangents here. So depending on this one, now we can say that there are different type of the curves. One may be the cusp, okay, and second is the node, and third one is the isolated, means imaginary. So in cusp, if the tangents are equal, okay, suppose x square equal to 0, it means that both the tangent are equal. Then there is a cusp. But if the tangents are suppose real and distinct, like this one, y is equal to plus minus x, then there is a node at the origin. So what will be the shape of the node? Node always it will be, because these are 2 different tangent. So this means that one is this one and second one is this one. Okay, so it means that now touching these 2 curve, 2 tangent, there will be a curve like this. It will go like this one and it will go like this one, so that it will be the tangent of this curve at the origin. This will be the tangent at the curve at the origin for this curve. So this y is equal to minus x and this is y is equal to x. These are 2 tangents which for which this curve will make a node at the origin. And for imaginary, if suppose the tangents are coming imaginary, means complex, then it is for the imaginary. So there is no graph of this imaginary tangents. Only we consider for the cusp, and second is for the node. Okay, so these are the natures of the tangent at the origin. If it is only x-axis or y-axis, then it's okay. But if there is the double tangent at the origin, then there will be a cusp. Double tangent means there will be the branches at the origin, taking x-axis or y-axis as a tangent. And similarly, if the tangents are real and distinct, there are 2 tangents, real and distinct, then there is a node at the origin. Then after getting, if suppose the curve does not passes through the origin, then what you will do? If the curve does not passes through the origin, then you have to shift the point, whatever the point will be there, for which it is not 0, means origin, then you have to shift that to the origin. Okay, by putting x, suppose it is at suppose minus a and b point. Okay, then you have to shift this as a replacing x as a x minus a, and this is y minus b, and then again equate the lowest degree term in capital X or capital Y to get the tangent at the origin. Okay, so it means that you have to shift the point to the origin by taking this transformation and then apply the same rule whatever you know in the earlier case. Now after this getting the tangent at the origin, then we go third point is the intersection with the coordinates. Intersection with coordinates. Coordinate axis. It means that if you put x is equal to 0, x is equal to 0 in the curve equation, y is equal to fx, then you can find out the point of intersection with the y-axis. And similarly, if you put y is equal to 0 in y is equal to fx, then you will find out the point of intersection on x-axis. So you can get the point of intersection on x or y-axis by putting x is equal to 0 or y is equal to 0. So you can find out whether the curve cross the y-axis or x-axis or not. So you can check by this to get the point of intersection. Then next point is the very important point that is known as the asymptote. Asymptote. You have to find out the asymptote. Asymptote, as I think you know about that one. If suppose there is a curve, okay, and at a fixed distance, means from the origin, there is a line. There is a line that is a finite distance from this origin. And also there is a distance between this curve and the straight line. So if this curve tending to infinity, alongside this straight line is also tending to infinity, and the distance between this curve A, now it is going to 0. It is going to 0 in the limit, but never cross this curve never cross this straight line, then this line is said to be the asymptote for this curve. Okay, so there is a line, a straight line. It may be parallel to the y-axis, it may be the parallel to the x-axis, or it may be along any line. The asymptote may be of this one also. So in this case also we define the same thing. As we extend this curve up to the infinity, extending this line up to the infinity, okay, the distance between this curve and the straight line going to 0 as it going tending to infinity, then and never cross this curve to the straight line, this is straight line, then we can say that this line is the asymptote for this curve. Okay, so you have to find out the asymptote, because once you find out the asymptote for the curve, then you will know, yes, the region for the curve is before this curve, this straight line. Otherwise, you will know don't know whether this curve will be going here or there, where it will go. So this line will decide, yes, if it is the asymptote, then it means that this curve, if we draw the curve in this coordinate system, then it will never cross this line. That's why we find out the asymptote for this curve. Okay, so there are different rules. Generally, you have to find out the asymptote parallel to the x-axis and parallel to the y-axis. Parallel to the y-axis. Generally, this type of the curve will come. So how you can get the asymptote parallel to the x-axis? Just you have to equate the coefficient of y, even power of y. Even power of y. So suppose it is given x square minus this is y square. Suppose here this is like this one. Suppose it is given. Okay. So here the coefficient of even power of y, that is y square, is 1, minus 1, you can say. So this is a constant. Okay. So if it is a constant, then we can say that there is no asymptote parallel to x-axis. Parallel to x-axis. Similarly, if even power of the coefficient of even power of x square, if we equate, then equating to 0, and if it is suppose some coming something, that is y is equal to suppose plus minus a, like it is coming suppose, then this is the asymptote parallel to this y-axis or x-axis. So whenever you equate the coefficient of even power of x or y, if it is constant here, as you see in the example, here it is constant. Therefore, you can say that there is no asymptote parallel to any axis, either x-axis or y-axis. Okay. But if you are getting something here, then you can say that yes, it is the asymptote parallel to x or y-axis. And sometimes suppose you don't find out the if the curve does not passes through the origin, then in that case you will not get like this equating the even power or x even power of x or y, but you have to put here this is y is equal to mx plus c, this one, because this is the line of y is equal to mx plus c. This is not x-axis or y-axis. Okay, so this is the line y is equal to mx plus c. So you have to put in the curve equation y is equal to mx plus c, and then again you have to apply this rule to find out the asymptote along this line, and this type of asymptote is said to be the oblique asymptote. That is said to be the oblique asymptote. Okay, so this is the rule to find out the asymptote, and after that you have to find some critical points. The critical points means just you find out dy by dx, where it will become 0 or it become infinity, at which point it becomes infinity or 0. So you can find out that dy by dx is nothing but this is the slope. So it means that their slope will be 0 or their tangent will be infinity. So by getting the critical point, you can say that tangents are parallel to the x-axis or y-axis. Okay, and after that you have to decide the region. You have to decide the region of the curve. You have to express y in terms of x, or you have to express x in terms of y. And you see for what value of x or y, this expression y or x becomes imaginary. It means that no part of the curve will lie after this point x is equal to a or y is equal to a, whatever it may come. So you can decide what is the region in which the curves lie. Just you have to see for what value of x and y the expression for y or x becomes imaginary. So it means that after that the curve will not lie. In between that the curve will be there. So after getting all these things, you can trace the curve. So if we take the very simple example, suppose y is square 2a minus x is equal to x cube. Suppose you have to trace this curve. Okay, so just you can see that there is the even power of y. Okay, y is square, here is x, here is x cube. So therefore even power of y is there. So we can say that this curve is symmetrical about the x-axis. Okay, after getting the symmetry, then we go further. This is the symmetry. Just you have to write down means when you do the problem, you have to write down some few lines about the tracing, not in the details. but something you have to write. Yes, symmetry. What is symmetry? Symmetry is about x-axis. Okay, second, we go for the tangent at the origin. Tangent at origin. So first we have to see that whether this curve passes through the origin. Yes, put x is equal to 0, x is equal to 0, we get y is equal to 0. So it means that the curve passes through the origin. If it passes through the origin, then you have to find out the tangent at the origin. So what is the lowest degree term in the curve equation? Just you have to find out. Okay. So what is the lowest degree term? Tell me, what is the lowest degree term? That is of 2ay square. Okay. 2ay square is the lowest degree term. So it means that you have to put this is equal to 0. It means that y square equal to 0. So it is means real and coincident. Real and equal tangents are there. Y is equal to 0. Y is equal to 0 means x-axis. X-axis is the tangent. X-axis is the tangent. Okay, and this is common for the curve. So it means that there is a branch at the origin. This shows that y square equal to 0, shows that there is the branch at the origin, and by this you make up the mind that the curve will be a cusp at the origin. Cusp at the origin. Okay, and after that now you have to find the asymptote. Yeah, point of intersection, suppose. So you can find out, you put x is equal to 0, you will get y equal to 0, or you putting y is equal to 0, you will get x is equal to 0. It means that only 0, 0 is the point of intersection. Only 0, 0 is the point of intersection. Intersection with the axis. With the axis. Okay. Now this is the third one, intersection with the axis. Now we go for the fourth one. That is the asymptote. Is there any asymptote for this curve? Then you will find out equating to 0 the coefficient of y square. The coefficient of y square. Okay. That is equal to 2a minus x. So this is 2a minus x equal to 0. It means that x is equal to 2a is the line of asymptote. So this is the asymptote, x is equal to 2a. And after that, now you have to express, let us consider the region of the curve. What is the region? Then you have to express this curve either in terms of x or y. So let us consider we are expressing this in terms of x. So y is equal to plus minus, and this is x square root of x over this is 2a minus x. Is it not? Yes, x is square root x over 2a minus x. Okay, now you have to see this is of a square root, so it should be positive only. Then we can trace the curve. And if it becomes imaginary, then we can't trace the curve. So for what value of x, it will give the real value. Just you have to see. Okay, so you will find out if x is less than 2a, if x is less than 2a, then you will find out this value as a real. So it means that and again, if suppose if you put you take x is less than 0, x is less than 0, x is less than 0, okay, it will be the positive, but here you see this will become negative. So again it will be the complex root. That's why x less than 0 and x greater than 2a, no curve of the curve is there, no part of the curve is there. So by taking all these, we can trace the curve this x-axis, the curve passes through the origin. There is a symmetry about the x-axis. Okay, so since this is the tangent, therefore the curve will originate here like this one, touching this x-axis, and it will go. And since it is symmetrical about the x-axis, therefore touching this x-axis below, a similar curve will be there. Now, where it will go, then there for that one there is a asymptote we have find out. This is x is equal to 2a is the asymptote. Okay, and the nature of this asymptote is that this curve will not cross this x is equal to 2a line. Okay, it will go up to infinity, but it will never cross this x-axis, x is equal to 2a. And also no part of the curve in x less than 0, because for x less than 0, it will becomes the imaginary. So totally the curve lie between x is equal to 0 and x is equal to 2a. And there is a, you can see here, there is a cusp at the origin. So if there is a cusp, then there will be a common tangent for this curve. And there will be two branches because y square equal to 0. So therefore there will be two branches of this curve. Mane curve is same, one. Only one curve is there. But at the origin, it branches in two. And that is this one. One is here and other is here. So this is the curve. Okay. And in application, what you will have to do, suppose you have to find out the area, length, surface, volume, then unless you know the region, how you can integrate it, whether it will be 2 times, 3 times, 4 times, how many times will be there by knowing, because this is the symmetry, you know. So if you find out the area for this region, you you take the 2 times of this one, you can find out the area for this whole region. So tracing is important to do the application of this integration. बोलो क्लियर है?
सर एक बार कस्प समझा दीजिए.
किसको? कस्प. Cusp actually I told you that this depends on the nature of the tangent. If there is only one tangent, either x-axis or y-axis, so there is no branches. Only one curve will go touching that tangent. Okay, but if tangent is more whose degree is more than 1, suppose this is y square, is here, it is coming, tangent is coming y square, or it is y is equal to plus minus x, like this one will come, means both the power of is lowest degree. Suppose y square minus x square equal to 0, both the power of x and y are, suppose this is the lowest degree, then it means that tangent will be plus minus x. Now this will be the real and distinct, but in this case here it is the equal, real and equal. So it means that there is a branch. If such type of tangent is coming, then there will be a branch at the origin. How many branch will be there? How many branches will be there? This will depend on this power. So if y square is there, it means that 2 branches are there at the origin. Okay, y cube is there, it means that there will be 3 branches there. So depending on the power of this y or x, you can say that at the origin, this will be the tangent common, but there will be 3, 4, 2 branches at the origin. Not only single, like x-axis is the tangent, then suppose for the parabola, this you can say only that this is the tangent. Okay, no, like this is not so here, because this is of y square. This is not only y, but it is y square. So if it is y square, so it means that 2 tangents are there, but these two tangents are real and equal. So if such things is there, then nature of the tangents will be cusp, and we can say that there is a cusp at the origin. But if the both tangents are real and distinct, then there is a node. And always node means always the curve will form like this one. ऐसे हमेशा बनेगा जब भी नोड होगा. क्यों? क्योंकि एक कर्व, ये देखो ब्रांचेस तो हो रहे हैं कि नहीं, एक इधर से इस तरीके से एक इधर जा रहा है और एक जो है ओरिजिन से फिर ऐसे जा रहा है. तो ये दो ब्रांचेज है, ये एक कर्व है, ये एक कर्व है, लेकिन ये ओरिजिन के बाद क्या हो रहा है, ये दो ब्रांचेज में चेंज हो जा रहा है. एक इधर जा रहा है, एक इधर जा रहा है. ये इसके लिए जो है y इज इक्वल टू एक्स टेंजेंट है, और इसके लिए सपोज y इज इक्वल टू माइनस एक्स टेंजेंट है. तो इस टाइप को हम कहते हैं नोड. दिस इज ऑफ नोड. तो देयर इज ए कस्प और देयर इज ए नोड. बट अगर y की वैल्यू सपोज प्लस माइनस आयोटा x आ गया तो वी कांट प्लॉट इट, वी कांट से इट. तो इमेजिनरी अगर रूट्स आ जाए तो हम उसको नहीं प्लॉट करेंगे. बट रियल एंड इक्वल, रियल एंड डिस्टिंक्ट के लिए ये कर्व का नेचर है एट द ओरिजिन. इधर इट विल बी कस्प और नोड. यस, और कोई पूछो, किसी को और डाउट हो?
सर रियल
और थोड़ा सा जोर से बोलो.
सर रियल कर्व में सिर्फ 4 ही कर्व आ सकते हैं या y इक्वल टू mx में सब आ सकता है?
क्या कह रहे हो, नहीं समझ में आया.
रियल कर्व में सिर्फ x इज इक्वल टू 0, y इज इक्वल टू 0, x इज इक्वल टू प्लस माइनस y ही आ सकता है या और भी आ सकते हैं?
और भी आ सकता है. आई एम नॉट सेइंग ओनली दिस वन. दिस डिपेंड ऑन द कर्व. आपको टेंजेंट एट द ओरिजिन ज्ञात करना है, लोएस्ट डिग्री टर्म आपको इक्वेट करना है. तो देखो कि लोएस्ट डिग्री टर्म क्या हो सकते हैं. तो वो जनरली होता तो यही है कि जनरली आपको या तो ये x इज इक्वल टू 0 मिले, या y इज इक्वल टू 0 मिले, या x स्क्वायर इक्वल टू 0 मिले, y स्क्वायर इक्वल टू 0 मिले, या y इज इक्वल टू प्लस माइनस x मिले. तो जनरली तो होता तो यही है कि यही सब मिलते हैं. लेकिन कोई एक ऐसे कोई प्रॉब्लम एकाकी मतलब कोई ऐसे प्रॉब्लम हो सकते हैं जिसमें आपको किसी और टाइप के टेंजेंट मिल सकते हो. बट जो मिलेगा जनरली वो आपको यही सब टेंजेंट मिलेंगे. या तो नोड बनाना है या तो कस्प बनाना है. और बताओ, और पूछो, किसी को और पूछना है? तो just we take one another example. Y square a minus x, this is equal to x square a plus x. So can you tell me the symmetry? Yes.
x and y दोनों के सिमेट्रिक हो गए.
x के राउंड x के सिमेट्रिक होगा सर. Only symmetry to x.
X-axis के राउंड.
only y is equal to
Sir, only x-axis is symmetric होगा.
Yeah, because only even power of y is there. है ना? Only y square a y square is there only. बाकी के लिए देखो ऑड हो जा रहा है. ठीक है ना? तो only even power of y आकर in the equation, therefore it is symmetrical about. तो symmetry about x-axis. Let us find out the tangent at the origin. Whether the curve passes through the origin. Yes, put x is equal to 0 here. You will get y equal to 0. The curve passes through the origin. So what is the tangent at the origin? Find out. Tangent at origin equating to 0 the coefficient, equating to 0 the lowest degree term. So what is lowest degree term? This is a y square here and this is a x square here. because this becomes here degree 3, this become degree 3. Okay, so lowest degree term is a y square minus x square, that is equal to 0. It means that y is equal to plus minus x, it is coming. तो जस्ट अब आपके दिमाग में आ गया होगा किस तरीके का फिगर बनने जा रहा है. क्या होगा? देयर इज ए नोड at origin. There is a node at origin. Why? Because the tangents are real and distinct. Real and distinct. That's why there is a node at the origin. Now after that, we get the point of intersection with the axis. So put y is equal to 0, you will get x is equal to 0. Similarly, put x is equal to 0, you will get y equal to 0. So it means that 0, 0 is the point of intersection only at origin. So 0, 0 is the point of intersection only. The curve cuts at 0, 0 only. Now next one, we come to the just you put y is equal to 0. Y is equal to 0, it means that you will get here putting y is equal to 0, and then you will get here x square a plus x is equal to 0. So it means that x is equal to 0 or x is equal to minus a. So it means that the point of intersection is 0, 0 and minus a0. This is the point of intersection with the x-axis. And what is the point of intersection with y-axis? Put x is equal to 0 now. Put x is equal to 0. So here if we put x is equal to 0, this is 0. Here put x is equal to 0, it means that y equal to 0. So it means that it will not cut the y-axis. It will cut at the origin only. So 0, 0 is the point of intersection with the y-axis. Then next one, now you have to find out the asymptote for this curve. So what is the asymptote for this curve? Tell me, what is the asymptote for this curve?
Plus minus a.
Not plus minus a. This is not plus minus a. You see what is the higher degree, a term of the x. X is x cube. Okay, and this is of x square. Its coefficient is constant. So therefore there is no asymptote parallel to the x-axis. And here the coefficient of y square, it is a minus x. And put this is equal to 0. So x is equal to a is the asymptote. है कि नहीं है? You have to equate the coefficient of highest power of x and highest power of y. So highest power of x, what is this? This is of x cube. Okay, so therefore its coefficient is 1. Therefore there is no asymptote. If it is 1, then no asymptote. Meaning if it is constant, no asymptote. Here the coefficient of y square is a minus x. That is x is equal to a is the asymptote. Then you find out what is the region. So for that one you have to trace this. Means write down the expression in terms of x or y. So you will find out in this form. So tell me what is the region for this curve. So if any curve, suppose x greater than a, then this becomes imaginary. So no part of the curve after x greater than x is equal to a. No part of the curve after x is equal to a. And similarly, if suppose x is that is less than minus a, x is less than minus a, then what you will get? This may becomes negative. Then again no part of the curve is there. So if you trace, now keeping all these things, if you trace the curve, so this is x is equal to a is the asymptote, and here is the point minus a0 is the point. So the curve will start from here, and you can find out the asymptote means tangent at this also point, so that you could know that what is the beginning of the curve, whether the curve will begin like this one, yeah, whether the curve will begin like this one. So you can find out the tangent at this point also. So you will find out the tangent money dy by dx you can calculate. If you find out dy by dx at this point, then it will be like this one, means you will get this parallel to the y-axis. Okay, it means that if this is the tangent at this point, then the curve will start like this one, not like this one. So if it will start like this one, and then since it curve passes through the origin, therefore it will go to the origin, and there is the tangent also here, and this tangent are both real and distinct. Therefore this will be the tangent for this curve. And similarly here it is symmetric about the x-axis. So below this curve, the same type of the curve will be there, and touching this line y is equal to x, it will go, and it will go up to this one. Mane we have made like this one, but it ultimately it will be parallel to the asymptote like this one, and here it will be parallel to the asymptote, and this will be the tangent. Okay, so this type of the tracing of this curve is there. So you practice this Cartesian tracing, and then in next time I will take a few more problem on tracing, because once you learn the tracing, then half the way of the applications will be over. Just you have to know about the formula, what is the formula, and then if you know the integration process of any function, then you can evaluate. Mane three things will be necessary to go to the application. First one is the curve tracing. Second one is the formula. Okay, whether it is for area, length, surface or volume. And third one will be the integration process. If you know integration for this function, then you can evaluate. So these three things are necessary for going to the application. So this is the first one. Whatever I have told here already, I think madam has taught to you about this curve tracing. And then next we go for this second. Second is the formula, and third is the integration. So I will give the rule for some function, how you can integrate. If suppose the integrand come like this, and then how you can integrate such type of the function. So after this, you can easily do the application process. ठीक है?
Yes sir.
बोलो.
Yes, sir.
Yes, sir.
ठीक है? सारा?
Yes, sir.
Yes, sir.
So just you tell me the attendance. I am calling roll number wise. Roll number 1. Just your.
Present, sir.
Okay.
Roll number 1, Adnan.
Okay. Roll number 2.
Present, sir.
Okay. 3, 4, 5, 6, 7, 6, 7, 8.
Sir, Aman Kumar.
Okay. 8, 9.
Present, sir.
Okay. 10.
Present, sir.
Okay. 11. Okay. 12.
Present, sir.
Okay. 13.
Present, sir.
Okay. 14. 15. 16.
Present, sir.
Okay. 17.
Present, sir.
Okay. 18.
17 present, sir.
Okay. 18. 19.
Present, sir.
Okay. 20.
Present, sir.
Excuse me, sir.
21.
21 present, sir. 21.
Okay. 22.
22 present, sir.
Okay. 23.
Present, sir.
Okay. 24. 25. 26. 27.
Present, sir. 27.
Okay. 28. 29.
Present, sir.
Okay. 30.
Present, sir. 30.
Okay. 31. 32.
32 present, sir.
Okay. 33.
Present, sir.
Okay. 34.
Present, sir.
Okay. 35.
Present, sir.
Okay. 36. 37.
Present, sir.
Okay. 38.
Present, sir.
Okay. 39. 40. 41. 42.
Present, sir.
Okay. 43. 44. 45.
Present, sir. 44
Okay.
present.
Okay. 45. 46. 47. Okay. 48.
Present, sir.
Okay. 49. 50.
Present, sir.
Okay. 51.
Present, sir.
Okay. 52. 53.
Present, sir.
Okay. 54.
So present, sir.
Okay. 55.
Present, sir.
Okay. 56. 57. 58. 59.
Present, sir.
Okay. 60.
Present, sir.
Okay. 61.
Present, sir.
Okay. 62. 63.
Present, sir.
Okay. 64. 65.
Present, sir.
Okay.
64
66.
present, sir.
Okay.
The 65 present.
Okay. 66.
Present, sir.
Okay. 67. 68.
Present, sir.
Okay. 69.
Present, sir.
Okay, 70.
Present, sir.
Okay, 71.
Present, sir.
Okay, 72.
Present, sir.
Okay, 73.
Present, sir.
Okay, 74.
Yes, sir.
Sir,
Okay, 75 is there.
sir, some people are saying attendance in the chat box because they don't have mics in their device.
I will
Sir,
check it.
74 present.
Okay, 74 के बाद भी रोल नंबर है.
Yes, sir.
Yes,
Yes,
sir.
sir.
78.
78.
Yes, sir.
Okay, 75. 76.
Present, sir.
Okay, 77.
Present, sir.
Okay, 78.
Present, sir.
Okay, और भी है.
और
Sir, 79.
सर 84 तक है
84 तक है.
सर
Okay.
बीच में 80 81 और 83 नहीं है 82 और 84 है
अच्छा, 79 and 80. 80 is not
Present,
there.
sir.
80 is there. Okay. 81.
Sir, 79. Sir, 79.
Okay, okay. 80. No. 81. No. 83. 82.
Present, sir.
Okay. 83. 84.
यस सर प्रेजेंट सर
Okay. Who has left?
Sir, roll number 4 and 64 is present. Their mic is not working.
Roll number 4 and
64.
okay. ठीक है. Okay, see you in the next class.
थैंक यू सर
Thank you, sir.
Thank you, sir.
थैंक यू
Thank you,
Thank you,
sir.
थैंक यू सर
Yes, sir.
Thank you, sir.
Thank you, sir.